so this is the review for Unit 2. I have a bunch of drills, I have a practice test, as well as some other practice called keys. So I'm going to go through all of them, and you can watch videos for all of it. I'm going to start with this drill, where we're asked to match the correct graph with the type of symmetry the graph maintains. So I'm going to look at this and look at all of my different options. Let's see more of these. Reflection over the y-axis. Let's look for that one first. So when I'm looking for reflection over the y-axis, I notice that that would be choice B, this one right here. Choice B is reflection over the y-axis. Rotation means to turn around the point 30. So somehow the point 30 has to be significant. Doesn't look like it here. Let's see right here, 30, here's that point. If I was to rotate this graph around this point, it would be symmetric. So that's going to be letter C for that one. Rotation about the origin. If I rotate it about the origin, that's going to be letter D here. No symmetry at all. Our square root graph right here has no symmetry. Okay. Let's move on to the other side, where it asks us to identify if the following are even, odd, or neither, and explain your answer using mathematics. All right, so let's look at this first graph. I would say this first one is odd because it is rotation symmetric around the origin. Look at this next one. This one is reflection symmetric over the y-axis, which makes that even, because it is reflection symmetric over the origin. Over the y-axis, sorry. I didn't mean to say origin, over the y-axis. Okay, so odd is rotation symmetric around the origin. Even is reflection symmetric over the y-axis. That's important for us to know. Now we're asked, number 6, to consider this function and prove if this is an even function. If I'm going to prove if something's even, I have to use the even test, which says f of x equals f at negative x. All right, so I've got to show each side of my proof. F at x is easy. I just say that that's the quantity x plus 2 squared. F at negative x. When I go to substitute into that negative x, since I already can tell I'm not going to know what happens when I add it to 2, I'm going to go ahead and expand this so that I can see all of it. And I get x squared plus 4x plus 4, because my outer term was 2x, and my inner term was 2x, which is where I got that 4x from. So this is actually my original function. So then f at negative x is going to be negative x plus 2 squared. And so I have negative x plus 2 times negative x plus 2. But here we get negative x times negative x is x squared. Negative 2x and negative 2x is negative 4x. 2 times 2 is 4. These are not the same, not equal, so it's not even. Okay, let's look at number 7. Consider the following function. And we need to prove this is an odd function. Well, that means we're going to have to use the odd test, which is f at negative x equals negative f of x. All right, let's do f at negative x. It's going to be 3 times negative x cubed minus 5. When you cube a negative, it simply becomes negative, because a negative times a negative is a positive, and a positive times a negative becomes a negative. And so I get negative 3x cubed minus 5. Let's see what negative f of x is. That's negative of 3x cubed minus 5. Then I distribute that, and I get negative 3x cubed plus 5. Once again, they are not equal, so it's not odd. All right, number 8 asks us, it says that the graph of f of x contains the point negative 3, 5. What other point must be on the graph of g of x if it is an odd function? Remember, when it's odd, x, y, rotates around the origin, so both x and y change. So let's see, negative 3, 5 is going to become positive 3, negative 5. Okay, that's my answer there. What other point must be on the graph if it is an even function? Well, when it's even, it just reflects over the y-axis, so the only thing that changes is x, which means my negative 3, 5 is going to become positive 3, 5. Notice only my x changed. What other point must be on the graph of the inverse of f? All right, well, inverse, that's when xy becomes yx. It's when x and y simply switch positions. So I'm going to get 5, negative 3. Okay. All right. My next, I have another drill that we're going to look at here. So suppose a transformation is a plot, or translation, it actually looks like, because I'm not multiplying anything here, is applied to the graph of y equals 3 divided by 5x minus 3. What are the equations of the asymptotes of the image? Well, I'm going to start off with the asymptotes of the original. Let's see. Normally, in my parent function, 1 over x, it looks like this. My asymptotes are x equals 0 and y equals 0, because I can't have anything here or here, so I have to put asymptotes there. Well, in this one, it's not going to be x equals 0. The thing that makes this 0, we know that 5x minus 3 is not allowed to equal 0, so I'm going to solve this. 5x can't equal 3. X cannot equal 3/5 or 0.6, which means I have to have an asymptote there. X equals 0.6. Well, if the denominator doesn't equal 0, then y is never going to equal 0, so y equals 0 is another asymptote. So here are my original asymptotes. X equals 0.6 and y equals 0. Now I'm going to apply the transformation x minus 5 and y plus 2. All right, this is going to get applied to this, and so then my new asymptotes, so x equals 0.6, I'm going to subtract 5, so I get x equals, would that be negative 4.4? That's correct. Okay. and then my other one, so what we can do here. And so 0 plus 2, y is 0, 0 plus 2 is 2. So here are my new asymptotes. My originals were not just x equals 0 and y equals 0, it was x equals 0.6, okay, because this denominator would have been 0 if x was 0.6. All right, this next one is a lot like the one we did at the bottom of the last page. 7, negative 2 is 1 point on a graph. What is another point on the graph if the graph is even? The graph is even, remember, the xy becomes opposite of xy as we reflect over that y-axis. So negative 7, negative 2. When it's odd, xy rotates around the graph and both x and y change. So we get negative 7, positive 2. And for an inverse, we simply switch x and y. So it becomes negative 2, 7. For number 3, we're asked to write a formula for f composed with g. So I'm going to take the g function and I'm going to put it in right here into the f function. So I get 4 minus this whole thing, 2x squared plus 9x. I'm subtracting all of this, which means that negative sign gets distributed. 4 minus 2x squared minus 9x. I do want to put that in descending order, so negative 2x squared minus 9x plus 4. Let's go on to the rest of this. We're asked to find the inverse of f, as well as the domain and range of the function. Right, so I normally think of this as y equals the square root of x plus 3 minus 7. So I need to switch. The first step I always do when I'm finding an inverse is to switch x and y. So x equals the square root of y plus 3 minus 7. I'm solving for y. Let's write that down and solve for y. Add 7. X plus 7 equals the square root of y plus 3. Got to get underneath that radical, which means I need to square both sides. And I'm going to suggest you leave this as x plus 7 squared equals y plus 3. Subtract 3 from both sides. So we get x plus 7 squared minus 3 equals y. And there is your inverse. The domain, we can see that it's a quadratic. Domain is therefore all reals. And the range, let's look at the range. When I look at this, actually, you know what? I can't do that. When I go to find the range, you could type this in your calculator, but I hope at this point you know that this is a quadratic that is moved to the left 7, 1, 2, 3, 4, 5, 6, 7, and down 3, right here, a quadratic opening up, which means my range starts at negative 3 and goes to infinity, or I could say y is greater than or equal to negative 3. Okay, all right, next. All right, so we are asked to write the translated function. So x plus 4 is actually in the equation going to be x minus 4 because x lies in the equation. And minus 5, y tells the truth, so that's simply going to be minus 5. So again, notice the translation rule says add 4, so the equation says minus. This says minus 5, therefore this says minus